Hi, I'm Ronan Collins. Today I'm going to speak to you about building information modeling and reality capture, how we can record what's happening on construction projects, and how we can use AR to predict what's going to happen in the future on our projects. So today is all about linking BIM to construction. My journey on this started back in 2009. We were building the Cathay Pacific air cargo terminal in Hong Kong, and I was responsible for managing the BIM on the project for the contractor. And one of the challenges that we had to overcome was making sure that the works that were undertaken on site were actually following the actual engineering and coordination drawings. So back in 2009, this was the early days of iPhones. And were using either our phones, but more often than not, we were using a standalone digital camera. And we would walk the job site and we would take photographs of key parts of the works. We would then get back to the construction offices, and then we would spend hours and hours going through Navisworks models trying to find where the locations were, and then bring up these kind of snapshots. And then we would create pretty much what I'm sharing with you now, a PowerPoint deck showing one image from the site and one image from the actual model. And the objective here was to basically demonstrate progress of the work and demonstrate that the contractors are actually installing as per the coordinated models. This was a very tedious process, and while it was 15 years ago, it's still very common on projects today that people are manually doing this. I'm going to show you a couple of technologies that are improving it. One of them is laser scanning. Laser scanning was the first technology we used to try and overcome the link between the digital world and the construction world. I'm going to share with you some experience with laser scanning. It is very, very good technology, but it tends to be the more expensive option when it comes to doing reality capture and construction progress monitoring. And it is quite common on most projects, or at least some projects. Another tool I'm going to share with you is augmented reality, and this would have allowed us to predict what was missing. So here you can see a couple of cable trays, but you'll realize that all of the green pipework is not actually installed yet. So having augmented reality back in 2009 would have been a really powerful way of predicting what had been missed or what had been left off the project. So in today's presentation, I'm going to share with you 3 technologies that you can use to record your project. And to make it easy, I say that reality capture is beneficial for recording what happened on site, or recording the past. So laser scanning is a really powerful technology. 360-degree cameras are the most popular tool right now. I think this is great technology. The hardware is improving rapidly. We're about to see the 4th iteration of the Insta cameras coming out. Longer battery life, better performance, better quality images. And the software that's being built around these is incredible. So there's a couple of platforms that people are using, and I'm going to share with you one of the ones that I find really, really useful. And the third part of this is drones. So for large infrastructure projects, for large area projects where you need aerial capture, drones are obviously the way to go. So there's 3 ways of doing it: scanning, 360 imagery, and drones. And I'm going to share with you how they can link back to BIM and why it's really important that you do that. There's not much point using these tools if you're not going to leverage the BIM with the actual reality capture. So going back to Hong Kong, this is the actual midfield concourse terminal project. This is a couple of years later, so this would have been around 2013, 2012, 2013. And on this project, we had a couple of unique problems. And we needed to survey the steelwork for the roof. The roof steelwork bottom cords were exposed, and we wanted to validate that they were actually installed in the right location, because we had to tie in the ceilings and a number of other things to them. So this was our first experience of using a Faro scanner. Again, I was working with the contractor. I had a team of people on site doing coordination for basically all the works. And what we did here was, this is an example. This is probably the first point cloud we captured. Point clouds are really, really dense. They get a lot of really valuable information. But in the days that we were doing them, it was difficult to manage them. So here you can see the end wall trusses for the curtain walling system tied into the roof trusses. And you can see the external part of the building. So we had to find ways of cutting down the point clouds into smaller blocks that we could then bring into tools like Navisworks to actually overlay them. The ability now to bring point clouds into tools like Revit is much, much better. It's much easier to do it. But back in those days, it was quite a cumbersome process. But what we were doing is we were validating that the point cloud, which you can see here in green, was tallying with the actual fabrication model. In this case, it was a Tekla structural model. So here you can see, of course, in a presentation, I'm always going to show you the good examples. In this case, the structural steel was pretty much installed as per the detailed model. So we knew that we were ready to go and install the ceilings. And this is a very, very accurate way of scanning what's happening on site. So we decided to use laser scanning because the area that we were scanning was inaccessible. But we discovered that we could actually scan more simpler structures. So this is a model of the Airlink bridge. This links the airplanes back to the main building. So what we were doing in this instance, the steel work was being fabricated in a factory in China. It was then shipped to the site on barges, and then they were hoisted and installed. And what we want to do is we wanted to validate and verify that all the plates for all the cladding systems were actually installed in the right locations. So traditionally, we would have wrapped the whole thing in scaffolding and then started measuring for the surveying. But what we actually did was we tried out on a couple of these bridges using point clouds. Now, while this looks like a drone image, it's just a camera flying around the point cloud. It's not really captured by drones. So all of the point clouds, and there's probably 60 different scans here, these were all merged. And you can see that we're still using the target spheres. I call them the white golf balls. They're all seen scattered throughout the models. So in this example, what we're doing is, again, comparing the structural steel on the job site to the actual fabrication models. So again, what we're looking for is the accuracy of the install. So you can see in some cases, slotted holes were missed out of the plates and they had to be drilled on site. Some of the plates were out of tolerance. They were actually not in tolerance. So we were able to identify where they were, and then we were able to cut and fix the cladding rails to solve that problem. So laser scanning is a very, very accurate way of actually scanning a job. Now you can see from when we did this back in 2012, 2013, still relatively speaking, a manual process in terms of linking the clouds to the models and then visually inspecting them, see what was going on. What I want to share with you now is basically where this technology has been developed to. And one of my really, really favorite tools is Nazca. And Nazca is now working with the same clients that I used to work with in Hong Kong. And I'm going to share with you two clips from how this technology works. But this is the kind of the forefront of what's possible now with laser scanning.
We are capturing data on construction sites using devices like the BOK2Go, which is really as easy as just walking around this device in your hand. You don't need costly surveyors to be able to capture all that information. Walk around, capture that high quality data, upload all of that to the cloud, and then what you have is raw data that our computer vision and machine learning algorithms then go to work on.
So the key distinctions here is it's a lot easier now to capture the point cloud data. And instead of processing it locally like we were 10 years ago, now it's all on the cloud. So you can see the benefits of these cloud solutions and all the algorithms and all the AI.
This means that we can immediately flag up risks on your project. Here, there's a penetration, there's a block out, it's missing. I can immediately see that it is in fact actually missing. Here, lift shaft is telling me it's deviated, it's been flagged up. I can visualize that deviation in 2 seconds, and I can see that the lift shaft doors are the wrong size, they're missing material on the top. That's obviously a problem. Get out ahead of that.
So these are really good examples of what is possible with laser scanning. So what's happening here is that the point cloud information is being tallied against the BIM information. So the models are being checked against the scans, and then they're basically using that to see what's differential on the site. So these are the leading edges in terms of what's possible with technology, but that's laser scanning, a really, really powerful way. I tell people laser scanning is probably the more expensive way of doing reality capture, but equally it's also the most accurate. For quick and easy and really, really impressive solutions, we recommend 360 cameras. And I did have one here earlier. I don't know where I put it. Well, it's here beside me. Excuse me. So this is a 360 camera. This is the X2. This is quite a small tool. This is brilliant. It lasts for a long, long time, but the image quality is not quite as good as the more recent 1-inch cameras. But 360 cameras are easy to use, quick to set up, and they capture some really, really valuable information. And a tool that I'm a big fan of is Cupix. Cupix is one of the solutions that's available. It's coming out of actually Korea. And we're using Cupix on a number of projects. And essentially, you can see how it works. You have a site engineer or a site representative walking around the site. The camera is mounted on their helmet. The recommendation is to walk around as if you're guiding your auntie or your granny around. So don't walk too fast, but just walk fast enough that you can cover the area. And the camera is capturing all of the site in 360. So it's basically creating a series of snapshots through a video. You can put the camera on a selfie stick and you can extend the camera into MEP spaces. So it's a good way of capturing areas that are not easily accessible. And I've been doing that on a project at the moment, getting about 4 meters, 5 meters up into the air into really confined spaces. So this is a really good way of capturing the site. The tool that we're using is Cupix Works. So it's easy to use, it's quick, and a bit like the previous software, it's all cloud-based. So once you've done your site capture, you upload all your video and your information to the cloud, and then it generates basically a 3-dimensional reality capture mesh. And in this case, they call it a dollhouse. So you can basically get a 3D model of your site from your walk around. And then you can start to unlock the value of the reality capture versus BIM. And this is where this tool is immensely powerful. So here you can see on the left is the reality capture imagery coming from the 360-degree camera. And on the right-hand side is a direct connection to the BIM. So they're using Forge to drive the models, but the models are uploaded directly into the Cubic software. And here you can see that on the left-hand side, you can move around in the side of your site virtually using the 360 capture image, and you can compare that to the actual construction work. Now, where this is really, really powerful is that you can actually then transpose or copy objects from the BIM directly into the reality capture mesh. So you can actually start to overlay certain systems that will be installed in the future into the actual reality mesh. So here you can start to see where the boundaries between the real world and the digital world start to cross over. And this is really, really useful technology, particularly for fitting out of works and understanding what's going to happen in the future. So that's the 360-degree cameras. Again, it's easy to use, it's quick to use, and a platform like Cupix is a really powerful way of actually implementing it. So moving on to the last tool when it comes to recording what's happening on the job site are drones. This is a really clever technology and one that I've been using on a number of projects. Here you can see the surveyors from Gamuda Engineering, and they're operating the drones in pairs. One is a drone spotter and one's a drone pilot. And these guys have all been trained. And essentially what they're doing is they're recording the site using a series of overlapping images. So the recording is predetermined. So the drone is flying on a predetermined path. So it looks like this. This is one drone recording another drone for the purpose of this presentation. So the drone flies over the site. It captures images which overlap by about 70%. And then from that, they can generate the data that we need to bring it into the BIM environment. So one key part of this is to have ground control points. And that's why the surveyors are the one that do the drones. So they know where they are, they know what's going on. And by incorporating the ground control points, once you've created the reality mesh, you can then link that back into the BIM environment very quickly and very accurately. So a couple of things that come out of this process. The first one is orthographic photographs. So this is the way of creating a true orthographic image. So this can be used in GIS. This can be used in CAD solutions if you're still using CAD. And because it's an true orthographic photograph in the site coordinates, it's a very useful way of actually being able to overlay information. So for comparison, this is a Google Earth image. You can see the lean of the buildings because of the way the images are taken from satellites. This is an ortho photograph of the same area, so you cannot see the building elevations. You see a true orthographic representation of the buildings. And then you can overlay things like tunnel alignments, works areas, access areas. So using drones to create ortho photographs is a very useful tool for the surveyors. But where it becomes even more useful in the environment of BIM is that you create this reality mesh. So this is a three-dimensional mesh of a station excavation for one of the metro stations. You can see the tunnel boring machine has arrived in the excavation, and you can see that they're casting the walls for the actual future station. So what we were doing is we were using this reality mesh, and you can see what it gets. It's not a very accurate mesh. The drones, you would need a lot more photographs to get a more fine-tuned mesh, but it's accurate enough that we can overlay the future civil engineering works like the major structural works, and we can see that we're reasonably well within tolerance in terms of what we're doing. Now, what we were using this for was monitoring progress. So we would fly over the site every month, sometimes every 2 weeks, and we would generate these 3D mesh. And those mesh were then compared to the BIM environment. So here you can see the base model for the station, the end walls, and then you can see how the mesh can be used month on month to demonstrate progress. And the great thing with these meshes is that they're dimensionally accurate. They're very, very detailed. And so a number of use cases come out of that. One of the most important use cases is actually surveying and volume measurement. So in this little example, I'm going to show you basically how we can use the reality capture mesh. This is a tool called context capture. And what we're doing here is we're basically, just for demonstration purposes, imagining that we have to create basically a platform. So we're basically identifying the area where we want to excavate. We're going to define the platform level at 28.5 meters. And then we're going to tell the software to run the algorithm at about 0.75 meter centers. And it will then give me a very accurate takeoff. So I can see that my cut and fill are reasonably well balanced. I need to cut 113,000 cubes of concrete, and I'm going to have to fill 98,000. So you can see that it's a very quick and very easy way of actually doing the survey. And this is a huge time saver. If I asked a survey team to go out and survey this area to give me this cut and fill balance, it would take them a couple of days. With a drone, I can do it in a couple of hours. So they're the reality capture tools, as we say, looking into the past. So what I want to do now is just touch on the other way of doing it, which is to predict into the future using augmented reality. And there's two solutions I'm going to share with you, one which we developed in-house and one which is now off the shelf and readily available. So back in 2019, augmented reality for construction was kind of in its infancy. There was a couple of solutions available, but for us, we decided we were going to use our own in-house team to develop a solution. So working with the Gamuda team and between the survey team, the engineering team, and the BIM team, we developed a tool using Unity. So we were able to take information from Revit, bring it across into Unity, and then we had an app that we'd built on the iOS platform, and then we were able to use that app to actually project the models into the job. Now, what we were trying to do in this instance was we were trying to mitigate against issues regarding coring of concrete. So once the walls were constructed, before the MEP was installed, we had to make sure that all of the openings and penetrations were available. So what this would look like was we could project pipes through the walls, we could project where cutouts were required. And if an opening was missing, we could then identify that and we can get that fixed pretty quickly. So the intention was to reduce the amount of coring on site, to reduce the amount of rework on site. But what the engineers discovered was that this was actually a more valuable tool if it was used earlier in the construction process. So what we started doing is we actually started providing the tool and working with the surveyors, worked out a way of identifying the locations before the walls were cast. So what we were able to do is we were able to tie the rebar and incorporate all the openings, incorporate all the cast-ins based on the information in BIM, based on the information on site, and make sure that we were actually casting the walls once and reducing again the amount of rework on site. So this was a very practical way of doing it. There was a number of constraints. We could only bring in one room at a time, and surveying was difficult. So because obviously the walls weren't built. But that was back in 2019. In 2024, we would recommend using a tool like Gamma AR. Gamma AR is a European-based software, and they've come a long way in terms of how their technology works. So again, using a mobile device, probably an iPad or a phone, you basically identify the surfaces in a known location, and then you pick the setting out point and you simply give it a direction. And now you can see that you've pinpointed your digital model inside the physical world. So here you can see basically the BIM environment inside the construction environment. You can change up and down the transparency so you can overlay one or the other. And then what you can do is you can then start to compare, oops, missed one. You can then start to identify issues on site. So again, like the other solutions, Gamma AR is cloud-based and it's connected to ACC. So you can generate images from the site using a mobile device. You can flag up issues. Maybe there's a penetration opening missing. Maybe something's not installed correctly. And you can basically align up the issues from the augmented reality from site and bring it back into ACC. So you can integrate what's happening with AR on site back to what's happening in your office in terms of coordination. So a couple of examples from Gamma AR, how this can be used on site. So here you can see them using an iPad, and they're looking at basically future works in terms of structure installation. This is really, really useful if you are trying to plan out lay down areas, craneage location, access areas, safety systems. Having this tool available to predict what's going to be going on in the future is really, really important. So again, this is a great tool for bringing a BIM model into the construction environment. As the job progresses, it becomes more useful when it comes to MEP systems. So again, you can actually overlay where you've designed and coordinated your ductwork and cable trays to be, and you can check that that's what's actually happening on site. A lot of the issues that we see in construction are around people installing things not in accordance with the engineering drawings, and then that requires reworking and fixing problems. So being able to pick up these non-conformances quickly and early is really, really important. So that's the technology that I want to share with you. They're really, really important technologies. They're going to transform the way we manage our projects, and they're going to unlock a lot of value in BIM. And it's taken us quite a number of years to get here. But what I would like to do before we wrap up is quickly give you a playbook as to how to implement these. So please don't go out and buy a 360 camera or buy a drone because it sounds like a great idea. What you need to do is you need to identify a use case and a business case for it. So the way I've set these up on my previous projects is we first of all define a problem. Do we want to reduce the amount of coring on a project? Do we want to improve the way we're monitoring progress? Do we want to improve the training on the projects? And how is that going to be a benefit? So we define the problem, we define what we're trying to solve as an issue. And then we have a pretty good go at working out what the potential savings are or what the productivity improvements are. What's the value in this initiative? What are we going to gain from it? So have your problem statement, have your value statement figured out. And then from that point, then start working out your plan of attack. Are you going to use drones? Are you going to use 360 cameras? What are you going to use? And then work out the potential solutions. Maybe there's 2 or 3 options and try them out. So what you do then is you identify a trial project. It could be a complete project. It could be a part of a project, a room or a floor or an area, and then run all the trials. Run the software, try it out, figure out what works, what doesn't work, figure out what processes are required, figure out if you need additional bits of kit to make it work. get the system working on a trial project basis, and then from there, once you've determined that it's going to work successfully, then you actually document what you're doing, you train up the staff, and you provide support to the team to actually use it on a more widespread basis, and then you continue to evaluate it. So that's my way of actually making sure that your investment and your commitment to these new technologies actually makes sense. And if it turns out the trial project does not provide the value you're expecting, then fine, you've still learned something, you can move on, and maybe you'll find another use case for the future. But go back and reevaluate what you're doing, come up with a new solution, and do another trial project. The more trials that you can execute, the more you're going to learn. I've been lucky, I've been able to try all these technologies out over certainly the last 10 years, and it's been really, really rewarding. And I recommend everybody should be looking at incorporating reality capture and BIM in your projects. And that's my presentation today. Thank you all very much.